We're going to solve some radical equations today. So let's first review just solving regular equations. You remember this. You would do inverse operations. So for the first one, we would subtract 5 from both sides, then divide both sides by 3, and your answer, oops, I didn't mean to do that. Your answer would be 4. For the second one, you've got variables on both sides, so you get them all on one side first. So I would subtract 2x from both sides, and subtract a 1 from both sides, and divide both sides by 2, and you would get your answer. Okay? Here we would solve, this is x divided by 7, so we would solve by multiplying both sides by 7, and our answer would be 35. Now, this one you've got factored form. Remember, when you multiply two things together and you get 0 as the product, then one of these has to be equal to 0. So what value would make this equal to 0 would be negative 7 and a positive 4. So you actually have two answers there. Okay? In this case, it is a quadratic. So we can use any of the methods that you want to solve for quadratics. Quadratic formula, you can factor, you can graph it, anyway, and you come up with two answers. And then again, here's another quadratic. We need to set it equal to 0, and we come up with two answers. So again, just remember that we're using inverse operations. Now, when you are squaring and taking the square root, those are considered inverse operations with each other, okay? So when you have a variable inside a square root, then we're going to square both sides to try to solve that. And that's what we're going to start with right now. Start doing. Okay? It's called the power property of equality. And basically it says that if you apply a power to both sides of an equation, you will have an equivalent equation. So in this case, you've got a square here. We're trying to solve for x, a square root. So we're going to square this side, and to be fair, we're going to square this side. The square root and the square cancel out with each other, and we get x is equal to 25. Okay, same thing here. I've got a square root. To get rid of that, I'm going to square it, which means I need to square this side, which gives me 100 is equal to, and the square root cancel out. That gives me 2x. Divide both sides by 2. X is equal to 50. Okay? And for our last one, again, everything's underneath the square root, so we square this side, square this side. We get 3x is equal to 1. Divide both sides by 3. X is equal to 1/3. Now, it's really easy to check to make sure that you're right. Just simply plug it in. If you put a 25 in here, the square root of 25 is what? It's 5. That checks. Here, put a 50 in here. 10 is equal to the square root of 2 times 50. So 10 is equal to the square root of 100. That one checks. Okay, and here, put the 1/3 there. 3 times 1/3 is 1, and the square root of 1 is equal to 1, and that checks. Now, not all the time is the radical sign already by itself. So if it isn't, for the most part, what you need to do is get it by itself. So here I would start out by adding 9 to both sides. Adding 4 to both sides. That gives me the square root of x is equal to 9. Then finish it by squaring both sides, and I get x is equal to 81. Again, you can check that answer very quickly, and it works. In this case, we're going to subtract 6 from both sides first. That's going to give me the square root of 5x plus 1 is equal to 4. Square both sides. 5x plus 1 is equal to 16. Subtract 1 from both sides and divide by 5, and you get x is equal to 3. Again, go back and check that, and you'll see that it works. Okay? Now, when you've got multiplication and division, you actually can do this two ways. I would suggest that you continue to isolate the square root, isolate the radical. So in this case, you would divide both sides by 4 first and get the square root of x is equal to 8. Square both sides, x is equal to 64. Now, you will get the same answer if you were to square both sides first. That would give you 16x is equal to a large number, and then divide both sides by 16, you'll still get the exact same answer. I just think it's easier to work with the smaller numbers. Okay, so in this case, I could, if I wanted to, square both sides first and get 36 is equal to x divided by 4, then divide both sides by 4. Or I can multiply both sides by 2 and get 12 is equal to the square root of x. Square both sides, x is equal to 144. Okay? All right, now we're going to try some harder ones. If I were you, I would stop the video now and kind of look at these and say, what would I do to solve these? And see if you can figure it out. Okay, so pause the video, take a look at that, and then I'm going to show you. Okay, for this first one, I would start by adding radical 6 to both sides. That's going to give you radical 5x minus 4 is equal to radical 6. Now, since both sides are radicals, I can square both sides, and the square and the square root get rid of each other, and I'm left with 5x minus 4 is equal to 6. And then we can go ahead and solve this, add 4 to both sides, divide by 5. X is equal to 2. You're going to do this next one the same way. So if you've got two radical signs in there and that's all you have, just get them on opposite sides. And then that way you can go ahead and just square both of them. And the square root and the square cancel out. And then you're left with just a plain equation that you need to solve, which I'm hoping that you can do easily. Here we're going to subtract x from both sides. Subtract 2 from both sides, and we will get x is equal to 2. Okay? You can check this really quickly. Put a 2 here. Put a 2 here. And we get 3 times 2 is 6 plus 2 is 8. And on here's 2 plus 6 is 8. So we get the square root of 8 is equal to the square root of 8, which is true, and checks. Okay? Sometimes when we are squaring to solve an equation, we create some extra answers that don't really work. We call those extraneous solutions, and that's why it's really important that once you have solved radical equation, you go back and check your answers. So on these two, let's make sure that we do that. I'm going to start here by subtracting 12 from both sides. That's going to give me the square root of 6x is equal to negative 6. Then I'm going to square both sides. That's going to give me 6x is equal to 36. Remember, this is in parentheses. And then I'm going to divide both sides by 6. X is equal to 6. So I actually got an answer. So now I'm going to go back and check that when I put that in there. That's going to give me 12 plus the square root of 6 times 6 is 36 equals 6. 12 plus the square root of 36 is 6 equals 6. This tells me that 18 is equal to 6. That's not true. This is what we call an extraneous solution. Okay, so in this case, there is no solution for this. All right, let's look at the next one here. I'm going to start out by squaring both sides. That's going to give me x squared is equal to the square root and the square are going to cancel out. It's going to give me 2x plus 3. I have a quadratic equation now. So I need to solve it using one of the quadratic methods. So I'm going to go ahead and set it equal to 0. Oops, it's minus 2x. I'm going to subtract 2x and 3 from both sides. So minus 2x minus 3 is equal to 0. You can put it in the quadratic formula. You can factor it. I'm just going to factor it because that works out pretty easily. Okay, and my solutions here are going to be 3 and negative 1. Again, I need to check it. Okay, so if I put a 3 in the original equation, 3 is equal to the square root of 2 times 3 plus 3. 3 is equal to the square root of 9. Yes, that's true. Let's put a negative 1 in here. Okay, ready? Negative 1 is equal to square root of 2 times negative 1 plus 3. Negative 1 is equal to the square root of 1. Well, the square root of 1 is actually 1. So this is an extraneous solution. Okay, so we're not going to use that. All right, let's try another one. In this case, I can't, I've isolated the absolute value, but I'm going to square both sides. Well, when I square this side, I'm squaring a binomial. Okay, so I have to use FOIL. So this side's going to give me x squared minus 4x plus 4 is equal to the square root and the square cancel out. That gives me an x. Now I have a quadratic. I need to solve it. Subtract x from both sides. X squared minus 5x plus 4 is equal to 0. Again, I can factor this one. X minus 4, x minus 1 is equal to 0. My solutions are 4 or 1. Again, let's check it really quickly. Ready? Let's put a 4 in here. 4 minus 2 is equal to the square root of 4. 2 is equal to 2. Check. Okay, let's put a 1 in there. 1 minus 2 is equal to the square root of 1. Negative 1 is equal to 1. Does not work. Extraneous solution. Okay, and that's it.